Hey gang, it's Mrs. Gregerson, and we are going to work on probably the hardest thing since we've really started this whole semester, and that's special right triangles. And yesterday we learned the 45-45-90 triangle, which we know is when you have an isosceles right triangle, and we know the legs are going to be the same, and the angles, acute angles, are both 45. And we discovered that we know that the two legs would be the same length and that the hypotenuse is just the leg times the square root of 2. So it was very easy to find the length of either the leg or the hypotenuse using this. And that pattern worked for any isosceles right triangle. Now, it had to be for an isosceles right triangle. Now, we're going to be working with one for 30, 60, 90 triangles. And if we were in class, I'd go to the board and I would draw a 30, 60, 90 triangle out. And I'd go, here's 30, here's 60, and I would make one that reflected across the longer side here. And I say, oh, look, that makes another 30, 60, 90 triangle. And then the whole big triangle would be an equilateral triangle, because all the sides would be the same. And I could use that to calculate the sides. So I'd say, oh, if that was 10, this was 10, oh yes, this segment would bisect the base, so that would be 5. And then I would just end up using the Pythagorean Theorem to solve for the longer leg of the 30, 60, 90 triangle. And so we'll just do it real quickly. And I get 25 plus x squared equals 100. Go x squared equals 75. Take the square root of it. X is going to be 5 root 3. And the cool thing is, if we did this for several different ones, the formula or the pattern would always hold true. Now, the hardest thing to get is the fact it's always a pattern. No matter what the nasty numbers are, we always have the same pattern for the triangles. And here's one thing we need to remember about our pattern. For a 30, 60, 90 triangle, all three angles are different. That means all three sides are different lengths. And so we name them to make it really easy. We name the side that's opposite the 30, that's your short leg. Because it's of the two legs, it's the shortest. And then we have our long leg. And then we have, naturally, the hypotenuse. Now, when we work with it, we can actually find the pattern that we had before. That pattern will always be based off of the shorter leg. So I always treat my short leg as home base. It never, ever goes away. So we call that x. Whatever measurement. Notice x is just the generic variable for finding that measurement. To get to the hypotenuse, if you notice here, this would have been my x. To get to the hypotenuse, it was doubled. So that would be 2 times x. So that was my hypotenuse length. My longer leg, once again, is based off of my short leg length. I call this home base. I go back to home base. And the longer leg is x times the square root of 3. Please make sure that the hypotenuse is always the hypotenuse on the diagram. A lot of people will incorrectly flip those two around, and it kind of ruins the whole concept behind it. But I just write down the different lengths. And I use the visual way of looking at this. I see this and I go, oh, hypotenuse to short leg, I just divide by 2. Couple rules. Larger to smaller, if I'm going from a larger side to a smaller side, you divide. Going from smaller to larger, we're going to multiply. So that doesn't change. So we're going to multiply it. So again, those rules stay the same as before. But for some people, it's actually better if they write out in words. The short leg is just going to be that short leg, but everything else is in terms of it. For instance, I know the long leg, and I'm just going to call that long, is going to be the short times root 3. And my hypotenuse is always just 2 times the short leg. And I can use that to calculate the different sides. And so I'm actually going to take a couple different approaches here. I'm going to show visual, then I'm going to use words, and then you'll see me probably use more visual, and once in a while I'll throw words in, because you have to decide what works best for you. But the one thing is true, this pattern never changes for any 30, 60, 90 triangle. So when you do this, I look at the very first one. And the thing that is the most important is, I told you, is home base. So you always want to identify that side. And that is always the side opposite the 30-degree angle. It's always the smallest one. So that is my short leg. That never changes. If I don't know the short leg, I have to find it first. So what side do I know? Well, I know the hypotenuse. Well, if I look here, the hypotenuse is 2 times x. Well, what's x? X is my short leg. So I'm going to go from the larger to the smaller. So I'm going to divide. What would I divide by? Well, what's the difference between these two? The number 2. So to get there, I literally would go, x is just 22 divided by 2. It's 11. So x is 11. But now how do I go to y? Well, y is the long leg, and the long leg is x times root 3. So that's the short leg times root 3. So I go y equals short leg, which is going to be 11 times root 3. So it's just 11 root 3. So that's y. Those are your two answers. It's not hard to do. But remember, I had to find the short leg to get the long leg, but the short leg is the best one you can have. So I look over here at B, and I go, okay, there is my short leg. That's exactly the one you want when you have a 30, 60, 90 triangle, because the other two are based off of that. So if I'm looking for x first, I'm going to solve for the long leg. Now, I'm going to use words this time to show it instead of using symbols. So if I'm going to the long leg, I know the long leg is just the short times root 3. So now I'm going to plug in the information I have. The long leg is x, the short leg is 5 times root 3. So what's my answer? 5 root 3. Now, how do I go ahead and get the hypotenuse? Well, I go back to the short leg, and I'm going to go short leg to hypotenuse. Visually, I go, oh, I double it, but if you're not sure, you can always write the words. Hypotenuse equals, okay, what do we have there? Short, or we should say 2 times the short. Let me change that here. 2 times the short leg. So that means the hypotenuse is y, so I put the y in for hypotenuse. I got 2 here. It's a little harder to read. 2 times the short leg, which is 5, which equals 10. So I get y equals 10, x is 5 root 3. Notice some of you could have done that quick verbally, and other ones of you want to write it down. I don't care which way works best for you, long as you understand how you get it. All right, let's get one last problem here, and then we'll go to the other side. Looking at this one, I have a 30, 60, 90 triangle. Looking at that triangle, here's my 30 degrees. That means this side is my short leg. If I don't have the short leg, I have to find the short leg. Well, what is the side I know? Well, I am knowing the long leg. So I'm going to do the visual this time, okay? I have long leg. I want to go to short leg, so I divide. What do I divide by? So I'm going this way. I'm going to divide by what? Well, what's the difference between these two? What two values? The variables stay the same. What's there? A root 3. I need to get rid of the root 3. So I divide by root 3. So what do I do now? I just go, all right, short leg. I'll just go, short leg is just the long leg divided by root 3. So it's 6. Now, the cool thing is, to get to the hypotenuse, I use the short leg, and I've already found the short leg. So to get to y, I go, all right, short leg, my hypotenuse is 2 times it, 2x. So to get to the hypotenuse, I multiply by 2. So just 6 times 2, that's equal to 12. So I know my hypotenuse is 12. Now, what if you are the word person? Well, you would come over here and you literally would have gone long equals, to find the short leg first, short times root 3. So I plug it in. My long is 6 root 3. Short would have been x. And then I'm going to times root 3. But I want to get x by itself. So I divide by root 3. Oh, look, those cancel out. X equals 6. So that's what we get for that one, x equals 6. And then I could use the same idea here. Hypotenuse is 2 times the short leg. Well, what do? Go, hypotenuse is y, 2 times, what's short leg? Oh, that's 6, equals 12. So your y would equal 12. Notice, I don't really care which one of these methods you use, long as it works for you and you get it right. Okay, now we have a lot of examples on the other side. I want to make sure we take time to do those.